Welcome to homework.
Okay, so when we have a circuit like this, when we have two loops and then we have two different batteries, we can apply Kirchhoff's law to do all the calculations. So in this problem, we need to find the current that are following through the circuit. So if we see, we have three different currents that are flowing through the circuit. One is I1, one is I2, and one is I3. Now, when we apply Kirchhoff's law, we always do two things. First, we apply junction rule, and then we apply loop rule. So the junction rule is basically when we have a junction, when we have three or more than three um, wires connecting at a point, we call it a junction. So for our case, we have two junctions here, so we can consider any of them, and then we can apply the junction rule, which tells us that if a current is going towards the junction, that should be equal to the current that is going out of the junction. So for our case, we see that I3 and I2 are coming towards the junction, and I1 is going out. So that means we can say that I1 is equal to I2 plus I3, because these two guys are coming towards the junction and this one is going out. And if we do the same thing in this junction, we see that I1 is now going in, but then I2 and I3 are going out. So it it's not necessary to do the same calculation twice, because we'll end up having the same expression. So that concludes our junction rule. Now we have to apply the loop rule. So as we see that there are two loops, so what we can do is, first we can start with the left one, which has 58-volt battery in it, and we consider a direction. So for our case, we are taking a counterclockwise direction, because that will make our calculation easier. So the loop rule tells us that if the direction that we chose is consistent with the direction of current, or if the direction of our loop is same as the direction of the current, then the voltage drop will be negative. And so for our case, we can see that I1 and our direction of the loop, they are in the same direction, because I1 is going like this and then our direction is this way as well. So then we'll have a negative voltage drop. So from Ohm's law, we'll have minus I1 times 120 ohms. And again for I2, we'll have a negative voltage drop as well. And since I1 is going, so sorry, for I1, so this I1 is again flowing through this resistor as well. So we'll have negative I1 times 76 ohms. And for I2, we see that the direction of I2 and the direction that we chose are the same. So that means we'll have another negative, and that's going to be I2 times 56 ohms. And in this setup, we see that the battery is going from negative to positive. And if that's the case, so that means there's a potential gain. So we'll have positive 58 volts for that. So if there's a potential gain, that's a positive sign. If there's a potential drop, then there's a negative sign, because we gained here, but then the voltage drops here, and then it drops here again, so that we get zero here. So that's why we got all those negative signs in front of it. So always remember, if the voltage drops, then there's a negative sign. Also, if our direction is consistent with the direction of the current, it's negative. So yeah, so that's going to be zero. So this is our loop rule 1 for the first loop, and we can do the same thing for second loop. Now for the second one, we can again take the counterclockwise direction, and if we do so, we see that for this guy it's positive, so it's going to be plus 3 volts. then it's going to be negative because I3 and our direction are same. So I3 times 25 ohms. Then now I2 is actually opposing our direction, so it's going against our set direction, so that means it will be a positive sign. It's going to be positive I2 times 56 ohms. Then for this case again, I3 will be the current, so this is going this way and our direction is this way as well, so it's going to be negative. And since we have 110 volts, so we multiply 110. So that's our loop rule applied on the second loop. Loop rule applied on the second loop. So let's call it loop 2. Let's call this loop 1. Right. So now we have 3 equations and we have 3 unknowns. So we'll be able to solve it. So I did all the calculations beforehand because it's a lengthy one, and so I'm going to tell you what I did here. So we simplified these two expressions and we got these two. So that's from our first loop, that's from our second loop, and this one is from our junction rule. Okay, so what we did here is we have I1 and I3. So we substituted I1 from this expression and we plugged it here. So that gave us an expression in terms of I2 and I3. Now the reason we want to do this is because our second equation has a dependency on I2 and I3. So we need this equation with I2 and I3 only so that we can compare these two. Now we have an expression like this and then we have this expression. So what we did was we substituted, or we solved the equation in terms of I2 so that we can substitute this I2 over here, and if we do so we get an expression of I3 only. So since this equation has only one unknown, we can solve for it and then we get something like this. So that's going to be 0.08961 amps. And once we know that, what we did was we substituted this I3 back in this expression, and that gave us the value for I2 because we know I3, so we can figure out I2. And once we know that, we substituted I3 and I2 on this expression, and that gave us the expression for I1. Now for the direction, I1 is going to be left, I2 is going to be up, and I3 is going to be left again. Okay, so we need to now find out the direction, or actually we need to find the direction when it's going through the resistor. So let's forget that and let's find out the direction when it's going through the resistor. Okay, so if we go back to the diagram, we see that I1 is going to 120 and 76, I2 is going to 56, and I3 is going to 25 and 110. So if we write those down over here, we see that 120 and 70, sorry, that's going to be 74. Yeah, that's going to be 74. There we go. So let me see if I corrected it here. Yeah, okay. Yeah, so that's going to be 74. Sorry. Yeah, so for 120 and 74, it's going to be this one, which is approximately 0.25. That's what I wrote here. And for the direction for 120, it's going to be down. For 74, it's going to be right. Then for 56 is the one where I2 is passing, so it's going to be up. and the current will be I2. So it's approximately 0.16. Direction is up. And again, for 25 and 110, it's going to be I3, but the direction for 25 is going to be left, and for 110, it's going to be up. So we had this, so we approximated that to 0.09 amps. Thank you.